Hello, my name is Chris and I'm an architect. Part of my job is to design things like buildings and bridges, but the really tricky part is to figure out how to design the loads for the huge amount of weight that will travel across some of these things. You've probably seen a real train. These trains can weigh as much as 120 tons, which is about 40 elephants or maybe about 4,000 kids your age. That's a lot of weight, isn't it? Can a train travel across any bridge? What's the material that's required for these bridges? But first, let's talk about the shapes that's involved in making the bridge. This is probably what you think of most bridges as. This is a basic plank, okay? Now, the problem with this is that there's no structure. There's nothing that holds it up. What this means is that when you apply weight to it, it just bends, okay? Now, you can take a plank like this and bend it a little bit, and we get a little bit more stability. It's a little bit better, but still not enough to hold a large amount of weight, like a train or cars. Now, when we start looking at basic geometric shapes, like this triangle, what we get is two legs and what we call a chord across the bottom. When you apply weight to something like this, it supports it, keeps it from falling apart. If we look at a shape like a square, same thing. We have a chord across the bottom, and we have two legs, and when you apply weight, the pieces don't want to move apart. Much more stable than our plank from earlier. So the question is, how to put something like this and something like this into a usable shape like the bridge, curved or straight? And the answer is this. This is what we call a truss. In a truss, it's a complex shape, but it's actually just a whole bunch of squares and triangles, and they all work together to prevent forces from pulling it apart. This is stable. So now how do we take this and move it into something huge, like a bridge? And the answer is something like this. This is a whole bunch of trusses put together that can be used this way as a road, this way as train tracks, but it follows the same rules as what we had before here, and in the square, and in the triangle. So this is just a truss bridge made out of cardboard, and it's actually surprisingly stiff and surprisingly strong for its size. Remember, most bridges are made out of steel and concrete. You've probably seen a lot of different types of bridges before. You've probably walked across them or driven in a car across them with your family. Some of these bridges are very small and narrow, and some of these bridges are very wide, almost like a 4-lane highway. There are all different types of bridges with trusses, or with arches, or mini arches, and another type hang on steel cables. This is called a suspension bridge. Why do you think there are so many different types of bridges? Behind me is the pedestrian bridge in Krakow, Poland. It might look different from some of the bridges that we've been talking about, like this truss bridge, but it actually follows all the same rules. It's a bunch of triangles, steel cables, and squares that come together to support the loads. Now, a bridge this size only has to support the loads of the people and the cyclists that walk across it. But for a much bigger bridge, structure and the pieces holding the bridge together would have to be much larger and much stronger. It's the job of the architects and engineers that design bridges to design for the amount of weight that's going to be traveling across that bridge. This means that they have to design the bridge to be strong enough and durable enough for all the elements and weights that are affecting the bridge. But how do we do that? What does this mean for the size or the amount of the structure? The first bridges were made by nature. These were probably a log or a vine that hung across a river, and man learned to use these to cross. Eventually, we began copying these designs. But today, a team of builders made up of architects, engineers, and contractors work together to design a bridge. They have a lot of pieces of the bridges to think about, such as the weather, the amount of weight that travels across it, the materials of the bridge, and the durability of the bridge. Thinking about all of these issues keep the bridge from falling down and keep the people that are using it safe. So now you know a little bit about the pieces of a bridge and the basic ideas for how to design one. Imagine that you need to cross a river like this in a car with your family. How would you design it? What issues would you consider when designing your bridge?